Welcome to the 2015 NASA Ames Summer Series. Throughout history, we have looked around us, both here on Earth and out in the universe, to start understanding where we are, where we came from, and where we're going. The more we have explored, the more we have learned about ourselves. Today's seminar, entitled A Cosmic End, From the Earth to the Universe, will be presented by Father Doctor José Funes. He is the director of the Vatican Observatory and received degrees, both a bachelor's degree in philosophy from the University of Del Salvador in Argentina, followed by a bachelor's degree in theology from the Pontifical Gregorian University in Rome. He has also received a master's degree in astronomy from the Universidad Nacional de Córdoba in Argentina, and a doctorate from the University of Padua in Italy. He joined the Vatican Observatory in 2000, and in 2006 became the director of the observatory. He has led, conducted, and worked with numerous conferences and research meetings. He has many scientific publications and is continuously working both on research and leading the Vatican Observatory. Please join me in welcoming Father Dr. José Funes.
Good morning, everyone. Thank you, Dr. Cohen, for this very nice presentation. And thank you for inviting me to be here. It's a real pleasure to be with you this morning. And I also would like to thank Monica Eber for arranging all the details for the talk. First of all, I would like to tell you one thing before telling a story. You already realize that. This is what I used to tell my students when I used to teach an introductory course in astronomy at the University of Arizona. The greatest challenge you will face in my class, it is not math, nor physics, it is my accent. So I have a strong Spanish-Argentinian accent. I will try to do my best. So. But this is what is important I wanted to say. When I was a kid, about 12 years old, in Argentina, in Córdoba, that's the time when kids start to think about becoming an astronomer, archaeologist, geologist, etc. So I was inspired by NASA. I was golden age of the exploration of space. And a classmate passed to me a list with the addresses of all NASA centers. So with my very rough English, I haven't made much progress, but I wrote a letter, and I asked my father to type that letter, and I sent it to one of the NASA centers asking for material. So they sent me materials about the Apollo mission, other NASA missions, and at the end it says, if you want to receive more material, send this money to this address. We were poor in Argentina. We are poor. So I didn't have the money, the dollars, to send it to NASA, so I tried a different center, NASA center. You know, when you don't have many resources, you have to be creative. So at the end, I got a lot of material from NASA. And I remember always looking forward the postman to bring the mail to my house. And I remember these brown packages coming from NASA. So I am inspired by your work. And I hope, this is my wish for NASA and people working at NASA, that you continue to inspire next generations. So, let's see what inspired me for this talk. As a director of the Vatican Observatory, I'm a member of the Pontifical Academy of Sciences. And I presented this talk in that meeting. And there was something that caught my attention in the booklet, and it said, human curiosity is the driving force for scientific development, in which belief systems and philosophies still have their valid place. So curiosity is the driving force for our research, for this talk, and also for curiosity. I couldn't not thinking curiosity, and of course this is a selfie. Also, in the address Pope Francis gave to the academicians, he said, to the scientists, and especially to the Christian scientists, corresponds the attitude to examine the future of humanity and the earth, and I would add, and the universe. And we have seen these days this concern of the Pope for the future of the earth with the recent document, papal document, encyclical. So before entering into this subject, I would like to, if I can, the $1 million answer. Question, sorry. This is, you can give me later $1 million for the answer. So why the Vatican is interested in astronomy? And the short answer is, who knows? But I need to tell you a story, otherwise it's difficult to explain why the Vatican is interested in astronomy. Here we have these popes. This is Pope Gregory XIII, who reformed the calendar that we use today. This is Pope Leo XIII, who in 1891 founded the Vatican Observatory. This is Pope Pius XI. With him, the observatory moved from the Vatican to Castel Gandolfo. This is the papal residence for the summer. In 2009, we moved from the Palace of the Pope. That used to be my office. It was very nice. But we had a wonderful residence now and headquarters. Here it is. You see the gardens. And because the history of the Vatican Observatory is similar to the history of other observatories around the world, we escaped to Arizona looking for dark skies. So in the 80s, the Vatican, a group of Jesuits from the Vatican Observatory arrived to Tucson, and we have a very good collaboration with the University of Arizona. This is the Department of Astronomy, Stewart Observatory, and this is the Vatican telescope on Mount Graham. This is Pope Benedict holding a meteorite from Mars, and the Osservatore Romano, the Vatican newspaper, published this picture on the first page of the newspaper with this headline, Mars in the hands of the Pope. This is my desk, the desk of the director, and here this Pope Benedict sign, and I explained to him that here there is the signatures. Maybe this is a unique document, the signatures of all popes since Pius XI to John Paul II, and I am telling him that with his signature and with the blessing of the new facilities, the Vatican Observatory is starting a new stage in the history of the observatory. Just a clarification. This is not a Vatican check. I'm not asking the Pope to sign a check for me. So this is our place. As you see, it's very nice. The Jesuits used to say, si hortum cum bibliotheca bebis, nil deerit. If you have a garden with a library, there is nothing you will lack. So we have a wonderful garden and a wonderful library with antique books too. So as Pope Benedict said to the participants of a colloquium we organized for the International Year of Astronomy, he said that, as you know, the history of the observatory is a very real way linked to the figure of Galileo. the controversies which surrounded his research and the Church's attempt to attain a correct and fruitful understanding of the relationship between science and religion. In few words, thanks to Galileo, I'm here. And thanks to Galileo, the Vatican Observatory contributes a little bit to the research in the world. Among our precious things, our little treasure, we have this astrolabe from the 16th century, and we have also, this is one example of the antique books. This is from Father, he was a Jesuit, Giovanni Battista Riccioli. This book is from 1651, and you see two systems are weighted. This is the Copernican system and the Tycho Brahe system, and the picture show at the time for the Jesuits, at least for this Jesuit, the Tycho Brahe was heavier. It had better foundation. Just a curiosity. What is our mission? As our colleagues, our deepest desire is to be on the frontier of astronomical research. And we try to address these questions as you do too. Are we alone in the universe? Are there other Earths? How do stars and planets form and evolve? How do galaxies form and evolve? What is dark matter and dark energy? What do we know about the universe in its first instance? Are there many universes? So these are some of the questions that inspires us. We also have a lab of meteorites. We have about 1,000 pieces, and this is the Martian meteorite that the Pope was holding in his hands. There is also in the Vatican the Pontifical Academy of Sciences, and in 2009 we organized a meeting on astrobiology that had a good impact. This is I like very much this quotation. I'm not going to read it all, but Cardinal Laiolo, he was the head of the Vatican State at the time. He said that about astrobiology. This task, the task of searching life and intelligent life, demands scientific integrity and an intense and indispensable case of the vast multidisciplinary research. For those of you, you know better than me that astrobiology requires to be an expert in many fields, which is something that is very difficult. He continues, in research, the scientists must also be allowed the possibility to walk paths which do not always lead to the positive results. Sometimes our research, we don't arrive to results, and the community, our countries, should allow us the possibility even to fail in our research, in our projects. Not always we may have a result. I remember when I was doing my PhD in astronomy in Padua, in my community, I was living with other Jesuits. I was the only astronomer, the only one doing research, and almost every day they would ask me, what did you discover today? And it's not always easy to answer that question. This meeting has had a lot of impact in the media at the time. You see the Washington Post, Time, ABC News, USA Today, ET found Rome, Vatican looks for signs of alien life. What is important, beyond these headlines, is that the Vatican is encouraging cutting-edge research because astrobiology, already we have this discipline for 20 years or so, is an important science, an important research. And the Vatican organizing and hosting this kind of meeting is considering this an important part of science. one important, very important activity we have at the Vatican Observatory are our summer schools. We have every 2 years students, grad students coming from all over the world, literally. In the last summer school, we have 25 students from 22 countries. There you see the audience we had with Pope Benedict. And the next summer school will be next year on water in the solar system and beyond. So if you're a student or you know students, of course, encourage them to apply for the school. It's a great experience. With John Paul II, the observatory had a great impulse in studies that not only involve science, but also philosophy and theology. So let's go to the talk, and let's, the universe, let's quote the universe. In the beginning is my end. In fact, it's not the universe. It is T.S. Eliot. Or better, is the universe talking through T.S. Eliot. In the initial conditions of the universe, there somehow is determined the end. So these are the questions that humanity has posed along centuries. Where are we? Where did we come from? Where are we going? And fortunately, scientists are not the only ones to raise those questions. I'm not an expert in arts and fine arts, but this is a painting by Paul Gauguin, and with this title, Where are we? Where did we come from? Where are we going? So there are different approaches to the beginning and to the end of the universe. Science is just one of them. So, as scientists, our starting point is the observed universe. We can only think the past and the future of the universe from its present and from the data we have collected and interpreted. We test our ideas with a reality check. I won't discuss in this presentation any biological evolution or technical development because it exceeds my knowledge. So I would like to say that we are a species with long eyes, and Galileo Galilei is our forefather. We use telescopes to reach where our eyes do not allow us to see. In Arizona, you of course know Kitt Peak, the National Observatory. There was a treaty between the US government and the Totonac O'odham tribe. And the Totonac O'odham tribe, they don't have a word for astronomers. So they use these words, the people with long eyes. We are people with long eyes, and telescopes are part somehow of ourselves. And with the data that we collect from the telescope, we can try to understand the beginning and the end of the universe. So what we know is that there is experimental data confirming the Big Bang. Briefly, we know the expansion of the universe, the Hubble's law, the cosmic background radiation, and we know also that the Big Bang theory correctly predicts the cosmic abundance of hydrogen, helium, and other light elements. We also know that this universe is accelerating in its expansion, and the Nobel Prize was given in 2009 for this discovery to Saul Perlmutter, Brian Schmidt, and Adam Riess. So we know that after the data from Planck, that the age of the universe is about 30.8 million years, and that the universe is made of basically dark matter, about 70%, baryonic matter, normal matter, just to say, about 5%, and dark energy, about 68%. we know that the universe is expanding and is accelerating, and this is, if we know that this is the present of the universe, this is what we can observe. There are different possibilities for the past and for the future of the universe. From the data we have collected, we know that we live in an accelerating universe, and in the oldest possibilities scenario, according to the data we know. I like to compare the age of the universe with other time scales for the rest of the talk. So one cosmic year is equal, for the sake of this presentation, to 14 billion solar years. What we can say about our future? Of course, the predictions will depend on the time scale that we use. Let's talk about a little bit of Earth, even it's not my field. It is very challenging to make any prediction for the future. And particularly regarding to the Earth, there are 4 geological processes that determine the shape of the surface of the Earth: the impact, the cratering, the volcanism, tectonics, and erosion. We need also to take into consideration into account the change in the atmosphere and the oceans, and the dynamical evolution of the Earth-Moon system. So things are very complex. Just in one slide, I am resuming, hopefully, about 14 billion years of story or more in 50 minutes. So you will forgive me if I miss something or I don't give enough details. But sometimes it's good to have a whole picture, a big picture. The image of the Earth in 3 billion years, about 0.2 cosmic years, is of a declining world. In 8 billion years, 0.6 cosmic year, the Sun will become a red giant expanding to the present orbit of the Earth. The Sun will expand, that expanse will expel a considerable part of its mass into space. And when the Sun expands to the current orbit of the Earth itself will have moved to almost twice its current distance from the Sun. Another thing that we need to take into account is the threat of near-Earth objects that might hit the Earth. And this is just a plot where you have the frequency for impacts and the size of the impactor. The craters are 10 times larger. And you see how often we may get these events on Earth. Just a recall of what happened recently in Russia. So we have records that these things really happen. And this is a simulation from ESA. For you may remember what happened when the Levi-Shoemaker comet in different fragments hit the Jupiter. So I'm sure you know all these images are very well known to you. So what we can say about the solar neighborhood? A nearby star could pass by about 3 light years from the Sun. This event could happen every 100,000 years. The Sun, also another possibility, is that likely is going to encounter a molecular cloud, maybe once or twice in 1 billion years, and the gravitational pull would cause a shower of comets that would may well increase the impact rate for these comets. Supernova threat. We also may suffer if we are still here, that the supernova occurs within 100, 200 light years from the sun, every 100 or 200 million years. This is likely to have a notable effect on the solar system. Our galaxy, we know that galaxies are composed by gas, dust, stars, and dark matter. In galaxies, we have a rotation. We can say that one galactic year is about 0.01 cosmic year, and we have this cycling of stars, gas, and dust that occurs within our galaxy. We know that galaxies also form clusters of galaxies, and they form and evolve. And we know that from galaxy evolution that there are two time scales in the evolution of galaxies. Galaxies are traces of the cosmic evolution in the last 13 billion years, and there are like two clocks shaping galaxies. There we have time or redshift here, and the looking back time here. This is the time of the clock of cosmic evolution for the whole universe. And then we have the time that is the clock that is giving us the stellar time related to the evolution of stars. For a star with one solar mass like our sun, this is the span life for the stars. When the stars become more massive, they live shorter lives. This diagram from Carmody and Kennicott show us different factors that intervene in the formation and evolution of galaxies. You have here internal processes on this side, and on the right side you have external processes. So inside the galaxy you have star formation, gas recycling, and the supernova production. And then on here you have also interaction with other galaxies through mergers, for example. On the top you have fast processes, and on the bottom you have low processes. You have the collapse of gas that will form the galaxy, and then you have very long-term processes, what we call secular evolution, that is driven by bars, dark matter, and other things in the galaxy. So in this video, it shows in the time of a cosmic year, about 14 billion years, the evolution and formation and transformation of galaxies. So this is what happened in about one cosmic year. I think you know the story. So the other thing that we know is the star formation history of the universe. Here again you have the star formation rate in the universe versus time. This is the present of the universe. So in the future the universe will form less and less stars. The universe was very much effective in forming stars between 1 and 3 billion years from the present. with Robert Kennicott some years ago in a team, we tried to study the star formation in the local universe, because at the time this wasn't a very well-known part of the diagram. We tried to add some points here. So what is going to happen with galaxies? In about 10 to 100 years, or 10 to 90 cosmic years, galaxies will fade into the darkness. Cluster of galaxies will become cluster of black holes. Finally, black holes will evaporate. In the very distant future, the universe eventually will be shredded, what is called the Big Rip. The universe could not have a single final end, but a multiple ends. The universe is going toward a final state of cold and darkness, thermal death, which says that the universe will go toward a state of maximum entropy, what is called the Big Freeze. The long-term scenario, with everything in the universe dying gradually, will be obviously hostile to life. This is not a very promising future for us, I guess. Using again the words of the poet, this is the way of the world ends, this is the way the world ends, this is the way the world ends. Not with a bang, but a whimper. T.S. Eliot. So at this point, this is until here, more or less, what we can say about from the scientific point of view. You can correct me in many things, but it's very difficult to say what is going to be the Earth, the Sun, our galaxy, and the universe as a whole. The beginning of this seminar was like going into a flight with all these indications, and I hope we are going to have a safe landing after this talk. But this has been a scientific voyage to the end of the universe, but it is also a spiritual journey to the final frontier of our existential frontier. I am final frontier. I'm sure you already had the background, the Star Trek. No, it's I'm a Star Trek fan, and so emptiness and questions. At this point of my talk, when I prepared this talk, I would say that it was also a spiritual experience to prepare this talk. Because somehow, I think Friedrich Nietzsche here summarized quite well what was my feelings. When you look long into the abyss, could be this empty universe, the abyss looks into you. Or putting in the words of the Bible, a vast emptiness, Coelho says, an immense void, everything is empty. So, is this the last word? I don't know. And just as we are used, maybe we have some kind of second episode. I would like to say what might happen, perhaps, with life. Life is resilient. We have many proofs of that. We have proof, you know better than me, in the extremophiles that are able to live in very hard conditions for life. We see sometimes flowers in places that we don't expect to see them. And this is the gardens in the Papal Summer Gardens in Castel Gandolfo. This used to be the house of the Emperor Domitian, who built his villa there. And you know, not many years ago, only about 2,000 years ago, people used to live here. Nobody's there, living right there, but there are so many trees that are living in these stones. I would like to say a word about astrobiology from a different point of view. I think for you, I hope, it's going to be new, and this is from a Jesuit, Father Angelo Secchi. I'm going to say in a second who he was. He wrote this in the late 1800s. What to think of this star without any doubt similar to our sun? I would say that's astrophysics. This time, like the sun, to keep alive an enormous quantity of creatures of every kind, biology. Those immense regions must be inhabited by intelligent beings, and though with reason, capable to know, love, and honor the Creator. And perhaps these inhabitants of the stars are more faithful than us to the duties of acknowledgement towards who draw them from nothing. We want to hope that among them there were not those unlucky that in their pride deny the existence of the Creator. And I would say that theology fiction, because he's speculating. We don't know that. We need first a proof. So who was Father Secchi? He was an Italian astronomer, a Jesuit. He was the director of the Observatory of the Roman College, which today is the Gregorian University. He was one of the pioneers in astronomical spectroscopy and was one of the first scientists to state that the sun was a star. He collected 4,000 stellar spectrograms, developed the first system of stellar classification, and discovered carbon stars. And I also would like to quote Martin Rees about our position in the cosmos today. The wider cosmos has a potential feature that could even be infinite. But will these vast expanses of time be filled with life, or as empty as the Earth's first sterile seas? The choice may depend on us this century. The most crucial location in space and time, apart from the Big Bang itself, could be here and now. I have some questions. If our location in the universe is crucial for life, all life will end with Earth. Is life a common phenomenon? What will happen with the life in trillions and trillions of years when the universe fades? Is there other universes? Will life survive in those places? Is there any other questions? An incomplete thought. I'm quoting here Pope Francis giving an address to the professor of theology and philosophy at the Gregorian University. The theologian who is satisfied with his complete and conclusive thought is mediocre. The good theologian and philosopher has an open that is an incomplete thought, always open to the malice of God and of the truth, always in development. And I would change a little bit the wording, and I would say the scientist who is satisfied with his or her complete and conclusive thought is mediocre. The good scientist has an open that is an incomplete thought, always open to the malice of the truth, always in development. And to conclude, I would like to end with incomplete matters, and then we can talk about this. We do not agree about the origin and the definition of life, an intelligent life. We do not know how to define a civilization. We don't know about dark matter and dark energy. We are still missing a theory of everything that may combine general relativity and quantum mechanics and the Standard Model. And of course, the list is incomplete and this presentation is incomplete. Thank you very much.
We have time for a few questions. If you have a question, please stand up, go to the middle aisle. There's a microphone, stand there, be succinct with your question, and move away from the microphone. So let me ask a question until someone gets the energy to move up and ask. I actually think, and I concur with the point of looking out there for learning more about ourselves. Is there any parts of the Vatican Observatory that looks at life in terms of us going and exploring other planets and how that sits within that arena?
That is a good question, and I would like to say that the observatory is a small group with employees and scientists, religious personnel. We are not more than around 20 people. So if we play for a moment, I don't know, passing from the cosmic years of NASA to our few numbers at the Vatican Observatory, the difference is huge. However, the Vatican Observatory considers that the search of life in the universe is an important thing. In 2005, the observatory organized, Father Cohen, at the time was the director, organized a summer school on astrobiology. In 2007, we organized a meeting on a school, again, on extrasolar planets and brown dwarfs. In 2009, we organized this workshop, study week, as it is called, at the Pontifical Academy of Sciences. And the next school, as I said, will be on water in the solar system and beyond. So this is to say that though we are not strictly involved in the search of life in the universe, we don't have a lab for that or the resources, we collaborate and we bring together scientists, students that are experts in the field and that they can help us to understand better the search of life in the universe. What I have to say that my training, scientific training, was in galaxies, nearby galaxies. But becoming director of the observatory, you realize that there is something else out there rather than galaxies, and you pay attention to other important topics. This is, I think, one important topic, not only for science, but also for a philosophical and religious approach. We can learn a lot, even from the search itself, even we don't arrive to positive results.
Thank you so much for the talk. One of the things I wondered about was you have probably a time allocation committee for the time on your telescopes, and you'll have some priority for what observations are made with that telescope. Could you tell us what programs you emphasize with your observations and how that addresses some of the questions you brought up?
We have our telescope, 75% is Vatican telescope and 25% it belongs to the University of Arizona. The programs, we have, I would say, quite a strong group in solar system. I consider them Brother Bob Mackey and Brother Guy Consolmagno, that you may know him, doing research with meteorites. And also we have Father Kikwaya from Congo, who is using our telescope and other telescopes and other cameras for the search of near-Earth objects. We also study the nearby stars that are similar to our sun, and this is related to the search of somehow the search of life in the universe. Father Corvally does this kind of research. Also, I've been using the telescope for star formation in nearby galaxies. We have, this is for the use of the telescope. Of course, you need other telescope to address those questions, but from the theoretical point of view also, we have Father Jonti, an Italian, who is studying, doing research on string theory and quantum gravity, just to show you that there is the other side of our research. Again, we do not cover all the fields. We try to be as much as we can involved in the research with our colleagues, and we have several collaborations. And the scientific meetings that we have organized and the schools is always a way to learn from our colleagues. We learn a lot from organizing these things and sharing their research interest.
I see that your talk shows that the Vatican Observatory has potentially a very long planning horizon in terms of thinking about the future. And I wonder if the Vatican Observatory has considered a time in the future when you would move into space telescopes for observation, and if you have given any thought possibility to promoting or sponsoring some form of space telescope.
Thank you. Before I forget, we have a website that is in progress. We have renewed the website. But if you go to the homepage, you can download, if you have some problem, I don't think so, but if you need some kind of sleeping aid, you can download. I'm kidding. It's very interesting, I should say. You have the annual report of the Vatican Observatory. It's very simple, vaticanobservatory.va, or you do Google Vatican Observatory, and there we have a document with the scientific priorities for the next 10 years of the observatory. Of course, we are small. We are not trying to compete with NASA or with the European agency. But we try to, within our possibilities, to be involved in science. Regarding the question about how to move to the next step of telescopes, I have addressed these questions with our staff when we prepare also that document. And at the moment, it looks like it's very difficult to have for us, a 20-meter telescope, a 30-meter telescope, though through the university, with a good collaboration with the University of Arizona, we may have access to those telescopes if we need them for the research. What we are doing now, and this is in progress, there is a plan for a network of small telescope, 2-meter telescope in southern Arizona, and this network is going to be robotized, and we are doing this. Our telescope is being robotized. Hopefully in about a year will be done, and we are doing this in collaboration with the University of Arizona. So this is, according to our possibilities, the way to keep the telescope updated and to address questions that may require space telescopes and other big telescopes. I've been collaborating with a team led by Rob Kennicott, and we use Hubble, Galax, and Spitzer. So we have access somehow to the data that these telescopes provide.
Hi, thank you so much for making the trip and making the time for the presentation. I was wondering, and I don't know if this is beyond the scope of the talk, I was wondering what you think the theological implications of discovering life would be. I don't know how else to phrase the question. Does it broaden it? Does it make it more magical? I would just, if you could spend just a couple of minutes talking about your personal view, that would be great. Thanks.
Sometimes I give interviews to journalists, and once one journalist asked me the following question: who would be the first person that you communicate if you find that there is a life in the universe? To the Pope, he said, and I said, to my mom. Being serious now, I would say first we need to make sure that we have discovered life, and that this life, I am someone that is not working in the field, but I think we need to be very careful that the life, if we find life, that this life has not been imported by us before. That would be, in any case, a great discovery to find life, even a very primitive form of life. Second, if there is intelligent life, I would like to say that it is already difficult to find intelligent life on Earth. We can imagine to find intelligent life in the universe. Just a joke. Don't take me too serious. But it's a very interesting question, and I think I'm working on that. I have some thoughts. We need to approach the possibility of discovering life from different points of view. The science point of view, of course, is important, but also from a philosophical or theological point of view. In my slides, I said something like, we don't know, I think, you can correct me, we don't agree with this life, how to define life. If we find life, what are we searching for? And the other point is that and this would be the debate for, I don't want to enter in this debate now, but what is a civilization? What do we call a civilization? What criteria we use to say this is a civilized world? I don't think that we can agree even on that today. And in the search of life itself, we can learn many things about ourselves and our origins. I think there is life, maybe in the universe, and even intelligent life, but for me, in my opinion, I think it's good. It will be very difficult to find life, and maybe intelligent. Maybe we are right to find life, but to find intelligent life, or that some kind of intelligent beings, ETs, would contact us. But that's my opinion.
Hi, thanks for coming and talking to us. So kind of similar to the last question, or touching on it at least, I'm interested to hear the way that religion is unique in how it makes truth claims, both about the nature of the universe itself, as well as how we ought to live, the relationship of those two things, and how, for example, Galileo, his discoveries affected, there were truth claims about the universe that affected also what religion had to say about how we ought to live. So aside from, whether or not there exists life on other planets, the different things that you're studying, the questions that you're pursuing, what are some areas that you see that these unanswered questions could possibly have the greatest change in what the Catholic Church says about how we ought to live? Thank you.
Well, one second intention of my talk was just to address these kind of concerns or questions or thoughts. How good science and religion could they interact? I'm learning, and I think Galileo was a very important event for the history of the Catholic Church, of course, but for the Western culture, the way we understand the relationship between science and religion. I don't think that this is my personal opinion. The discovery of life, of intelligent life, would have a great impact in the Catholic faith or the Christian faith. I think we have sorry to do some kind of advertising, but I'm still reading it. This because it was published last week and I was traveling. I started to read the encyclical by Pope Francis I'm reading it in Spanish, so on the concern, I would say, of the common house or common home, he used those terms. I think it's new in the approach he has to this problem, because he considered the results coming from science, but also he considered other perspectives from the economic point of view, from ethical point of view, from a religious point of view, but it's quite universal. He's trying to reach not only Catholic, but everyone on the earth. I think there we have a good example, a good model, in the way that science, philosophers, or even people working in culture, with anthropologists, for example, and religious from different confessions, Christians, Jewish, Muslims. I think we need to move in that way. For me, one kind of thing that I'm learning in this last year is that it's important, the dialogue between science and religion, but not only in the context of the Catholic Church, in the context of Galileo, but also in the context in the dialogue with other religions. I don't know, but in Europe, this is my impression. I don't know much here in the US, but the interreligious dialogue is urgent. It's urgent. And maybe science could be a helpful language to help to understand people from different religions. So that's my hope.
I guess I'm the final question. It's obvious when you're talking, you have a great command of astronomical data, and I know from your background you believe the Bible and the stories that are obtained therein. I guess what I want to know was, in the book of Revelation, the end of the earth is predicted, and also the creation of a new earth. And I was hoping, coming into this talk, that you would speak to that, being well-footed in both those. Do you have any comments on that you could share briefly?
Okay, yes. I have to confess that I had one extra slide addressing your question, but because I didn't want to make a direct reference to the Bible regarding this. This is a question that requires a long answer. I'm going to try to be short. I am short. The Bible, this is for Catholics, so the mainstream Catholics. And I would say for the church, for the authority of the church. the Bible is not a book of science. I repeat, the Bible is not a book of science. If we have scientific questions, we shouldn't search the answers in the Bible. What is the Bible? The Bible is the book that we believe. I believe in God. I am a scientist, but I believe in God. The Bible is a book inspired by God, written by men and women, I don't know, that was written with a language that was used sometime 3,000 years ago. The sacred authors, they didn't know anything about the theory of the relativity of quantum physics. They wanted to answer the big questions that we have, those questions that I put it in the past. I would say this, I would use this image. Now people don't write anymore love letters. They send emails, maybe old people maybe still, or SMS or a message or iMessage or WhatsApp. But maybe today God could speak using WhatsApp or Twitter, I don't know. But I would say the Bible is the letter of love that he or she has sent to his people, to us, with a language that is a language of 3,000, 2,000 years ago. How is it that? The book of Revelation, the meaning, this is my understanding, it's not about the end, how the universe will end in the sense of what would happen to galaxies, to stars, but it gives us the sense, the meaning of human history. Where are we going? It was written in a time, maybe similar to our time, in which Christians were persecuted. So St. John, he's trying to give hope, a message of hope to this community that is suffering from persecution. And what he's saying is that God is conducting this human history with all difficulties and with all problems we see, and that the profound fundaments of this history, human history, and why not history of the universe, are in the hands of God. This is very difficult to explain and to say using scientific language, because it's a different, we need to read the Bible with a different language. So I would say that for the book of Revelation. Of course, it's a very complicated book with many symbols, but in a short answer, that would be my reply to you.
So please join me in thanking Father Dr. José Funes.